This video is about solving derivations using the top-down approach. To use the top-down approach, it's going to be useful to rewrite our inference rules in a different order. We're going to list first all our one-premise rules. These are rules of inference that have only one premise, the OR introduction and elimination in both versions. Then we're going to list our two-premise inference rules. That's the AND introduction and the arrow elimination. Each of these requires two premises. And then finally, we're going to list the rules that use secondary assumptions. And there are three of these: arrow introduction, negation introduction, and negation elimination. And I want to notice something unique about these two in this last group, the arrow introduction and the negation introduction. Both begin making the same assumption, P. But the difference is that to use an arrow introduction, I derive Q, which is the consequent of the conditional. Then I discharge my assumption and infer P arrow Q. Whereas with the negation introduction, I start with P and then I derive Q and a negation of Q, some sentence and its negation. I'm deriving a contradiction so that I can infer the negation of P. So now let's suppose we're trying to solve this problem. We're trying to derive A from the sentence that is the negation of A arrow B. And what I've done here is I've made a little chart with our one premise rules, our two premise rules, and the rules that require secondary assumptions. And I've boxed off the negation rules because they're unique. They're the only ones where I have to derive a contradiction. So now, what I'm going to try to think about is, what can I infer? What steps can I take to go forward and go down the page and work my way toward deriving A? And very quickly, I can rule out certain choices because, for example, I'm not going to use the rule that is an AND elimination rule on line 1 because there is no AND to eliminate. The main logical connective of the sentence on line 1 is not AND, so I'm not going to use the AND elimination rule. I'm also not going to use the AND introduction rule because that requires two premises. I only have one. I only have one sentence, so I can't join anything with an AND. And similarly, I can't use the arrow elimination rule because that requires two premises. It requires a conditional and then the antecedent of the conditional, and I don't have that, so I won't be using that right away. I know that for sure. I could use the OR introduction rule technically. For example, I could do something like this and then OR anything else here, but that's not getting me closer to a single sentence letter. In fact, it's giving me sentences that are longer, and it's not at all obvious how that will help me get toward A. So, although I cannot definitively rule it out, I'm going to rule it out for now because I'm pretty sure that that's not going to be helpful. Turning to the rules that use auxiliary assumptions, I have the arrow introduction rule. I could think about introducing a conditional here, but again, it's not really clear why that would help me. Even if I could derive something like A arrow B, that's not going to help me derive A right because I'm already next to the leftmost scope line. So this does not look like it's a very promising strategy. And suddenly I'm down to the two negation rules. I've ruled out anything else as a reasonable way to step forward and work my way down the page using a logical inference. So, given these two choices, negation introduction or negation elimination, negation introduction here doesn't seem to be very useful because what I want to derive is A, which does not have a negation. And so I'm pretty much restricted now to really thinking about trying to complete my derivation by first assuming neg A. Now, all of that thinking, as long as I'm systematic about it, can lead us to a solution, because now that I've got the assumption that neg A, I have two sentences to work with. Before I only had one. And I remember something else about the negation elimination rule. It was in this little box because I know I have to derive a contradiction. That's an important thing to remember, because to derive a contradiction here, it has to be something that I derive using lines 1 and 2. The previous reasoning that we that we went through thinking about what we could do with line 1 tells us something else. There is nothing we can do with line 1 to transform its shape to be anything else other than adding a disjunction, which is not very useful. And so that tells me that the only way I'm going to use line 1 is by using it as half of a contradiction. And I have to use line 1. Why do I know that I have to use line 1? Because I know that the inference neg A, therefore contradiction, is invalid. I cannot derive a contradiction down here simply from neg A. I have to use line 1. So to use line 1, I'm going to think that I'm going to use it as half of a contradiction. So I'm going to be reiterating it down here. And that means that I have to set my mind on deriving A arrow B. And here is where, we're not exactly going strictly top down. We're starting to do a little bit of bottom up thinking, but it's what we need to do to see where we're going. Because if we don't think about where we're going, then you can just spend a lot of time trying different things and failing. So now that I know that I have to try to derive A arrow B, now it's very simple because the only way to derive A arrow B here is by assuming the antecedent and trying to derive the conclusion. So let me clean this up a little bit now that we know where we're going. So now I'm going to try this. I'm going to assume the antecedent, and I'm trying to derive B, but as soon as I assume the antecedent, I notice a really important pattern here. I want you to pay really close attention to this pattern. Starting at line 4, if I keep my line numbers here carefully on my page, starting at line 4, right here, I have access to anything above and to the left. So I have access to A, neg A, and then the negation of A arrow B. Because I have access to both A and neg A, I can derive anything I want because this is going to be a contradiction. And that's a really important pattern to see. You'll see it coming up a lot in different derivations that we do. So now that you notice that, if you remember that what we're setting out to do is derive B, then the derivation is very simple because you just need to assume the negation of B, reiterate A and reiterate neg A, and then you can infer B, and now you've got A arrow B. You're almost done. You just need to reiterate the negation of A arrow B down here, and then you can infer A. Okay, so if I number all my lines carefully, that's the complete derivation. And I'll leave it to you to write all the justifications for all of the lines.